Hello world, my name is Kshitij, this is the coding tree, and today we're talking about two-dimensional lists. Last time we went over normal lists, where we were able to store multiple pieces of data in individual variables. Using these concepts, we were able to make a list of office characters and check if whatever the user inputs is in that list, thus checking if the user's input is actually an office character. Using arrays and lists for this is a lot more convenient than using anything else. That's great, but it does have its shortcomings. Thing is, we don't live in a world that only needs one dimension of information to store. We live in a world that's 3D, but we also have 2D planes that we use in our day-to-day lives. For example, your smartphone is just a 2D screen that we're using in a 3D world. So, how do we represent 2D information in computer science? Let's elaborate on what I mean using the example of the game Tic-Tac-Toe. When we play Tic-Tac-Toe, something we never really think about is how our information is stored. I mean, obviously, we have the classic Tic-Tac-Toe grid, which just visually represents the data that we input in. But how would that look through code? After all, as computer scientists, we have to think about implementing real-world situations into code. And that's what we're going to do by looking at how a tic-tac-toe board works. We have to utilize two-dimensional lists for this. You can imagine 2D lists as a grid. So now we're going to store the tic-tac-toe information in a 3x3 grid because there's one square per row, and there are 3 rows. We have to use two-dimensional lists for this. You can think of 2D lists as a kind of grid, where you can store multiple pieces of information in a way that is visually 2D. So, we can store the entire tic-tac-toe board in one 2D list, with 3 rows and 3 columns. But how do we actually create the list in Python? Well, for that, I have to give you a little bit of a secret. Be aware, I can't share this with anyone. Are you ready? The secret is 2D lists are just lists inside of lists. 2D lists are just lists inside of lists. That's all they really are. But using these concepts, we can represent full-on grids. To my left, you can see what this looks like, but it can be a little confusing, what with all the brackets and the commas. So don't worry, Python lets us add spacing so we can better visually represent a 2D list. So there, that's a little better. So what we're doing right now is just storing a list inside of a list. Particularly, we're storing 3 lists, with each containing 1, 2, 3, 4, 5, 6, and 7, 8, 9 inside of a mega list that contains those as rows. Now, let's try to figure out how we can access specific information in the 2D list. Although that might seem scary at first, it's really not that bad. We can, again, just use square brackets as we did last time with 1D lists. And again, these will be numbered starting at 0 because computer scientists start counting at 0. Let's see if I can access a value in this board. Well, what if I wanted to access the value 6? How would I get there? You can think of a 2D list as follows. The top left number, the very first one, can be represented by a row of 0 and a column of 0. So, because of that, we can say that board, open square bracket, 0, closing square bracket, and then again, open square bracket, 0, closing square bracket, accesses the first position, which is 1. When I go down 1 from that, I increase the row number. So, the very first 0 goes up by 1 as we go down 1. The opposite happens with going right. The second number increases by 1 if I go right. So, back to the question, how would I access the number 6? Well, 6 is on the second row. So, I'd have to go down 1 to get to the second row from 0. So, I can have 1 in the first open square bracket, close square bracket. Next, I have to go right twice to get to 6 because it's in the third column. And the index of the third column is 2. So I can do board 1 because of 6 being in the second row, and then 2 because of 6 being in the third column. That essentially gives me 6. So if I write print board 1, 2, I get 6 back out. So as you can kind of tell, all we're really doing is adding another dimension to lists. And as the name suggests, that's all 2D lists are. Okay, let's try something even weirder now. Let's try printing out the board, formatted correctly, using for loops. So for that, we have to introduce yet another new concept, nested for loops. These for loops are essentially just for loops that are inside of other for loops. So if I write for I in range X, and I write for K in range Y underneath it, every time X runs once, the for loop underneath it runs a Y number of times. Wow, there are a lot of things inside of other things in this episode. Maybe I should call it the Inception episode. So while they seem a little bit scary at first, nested for loops are just really simple. All it is looping that many times on each iteration of the first loop. But in order to actually loop, we have to introduce yet another concept, len. Len is a built-in function in Python that gives us the length of arrays, lists, and strings. But it can't just give us the length of the entire board. Because it's a 2D list, it has different length values for the number of columns and the number of rows. Sure, since this is a 3x3, those numbers are the same, but it's good programming practice to assume that they are different. Let's assume it's a 3x4 or 3x5. Then our code would not work if we just inputted 3. So I can do range len board for the first part, and then for the second nested loop, I can do range len board open square bracket 0 closing square bracket. Why do I do this? Well, if I add that bit of syntax, we essentially get back the length of the columns and not the rows, which allows us to look at the other dimension, and if that dimension was 4, then it will loop 4 times there instead of 3. You might be wondering, why do we even need to use the len function in the first place? Well, because the way that Python loops work, if we just used range, what would happen is that I would be assigned to 1, 2, 3. Essentially the numbers that are actually inside rather than the indices. Since we put len, I is being assigned to the indices of those numbers rather than the numbers themselves, which allows us to actually decide on what we're going to print out. So now let's just add a simple print statement at the end of the second loop, where we write print board open square bracket I closing square bracket open square bracket K closing square bracket. So what we're doing is just we're looking at the number that I is at, and then we're looking at the number that K is at, and we're printing on that location. So let's try running our program, and everything printed, but it didn't print correctly. Everything was on a new line, and there was no indication that this was actually a 2D list. So let's fix that. You may have noticed that every time we print something in Python, we create a new line. Well, there's actually a workaround for this. Basically what's happening right now is that a new line is created every single time, and we don't want that for the purposes of this program. So we can add a second condition to the print statement. The first condition is what we're actually printing, and then after that we write comma, end is equal to something, then we can dictate what the ending is going to be. By default, the ending is a new line, but we can change it to be, let's say, a space. So if I write inside of the nested for loop, print board ik comma, end is equal to open quotation mark, space. So now the end is always going to be a space and then closing quotation mark. I'm essentially doing just that. I'm designating my own ending to a print statement. So let's try running this code now. And that's even weirder. Now everything is printing, but on the same line. How do I go about adding a new line only when we reach the end of one line itself, if it's always just going to print with a space? Well, for this, I can actually do something quite clever. Let me break out of the nested for loop and go into the original for loop. Here, after the nested for loop is done printing, I can write a print with nothing inside of it. What this will do is print a new line after the nested for loop is done running. And since the nested for loop prints everything in a certain row, I'm essentially creating a new line after that certain row is done printing. So let me hit run on the program, and boom! It works exactly as intended. It prints all of the numbers and it prints new lines each time. Learning about 2D arrays is an essential step in understanding the fundamentals of visualizing data in computer science. That's all for now, folks. I hope you enjoyed and I hope you learned something. If you did, make sure to like, and if you want to continue your computer science journey, you can subscribe. Click here to watch the next episode.